If we start off with an exponential function like we have here, there's a couple of names that we want to make sure that we know. So for an exponential function, this b is what we call the base. The x obviously is the exponent, right, so nothing kind of crazy there. And well, this y value, the output. A lot of times when we work with exponential functions, or when we work with logarithms, as we are in a second, we just call this like the number, which isn't a great name for it. Sometimes the value, but basically it's the output. It's the y coordinates on the exponential function. So in a previous video, I talked about the fact that a logarithm is an inverse of an exponential. Is an inverse of an exponential. So again, what that does is it means that a logarithm will basically undo an exponential. Right? So just as an aside, if we had something like x squared was equal to 25, and we want to undo this, well, the inverse function for squaring is square rooting. So we would say that x would equal this plus or minus of 5. Couple of things here that are probably pretty kind of evident now that you've worked with square roots for a really long time in your life. This square root is basically just a symbol. It represents what we're about to do to the x squared, right? You would never in your life think that this means the square root, the symbol. Let me get that a little bit clearer. You'd never think this meant like the square root, the symbol, times x squared. That would be just like incorrect. That's crazy. So when we look at exponential functions, right, so if I start with this y is equal to b to the x, and our goal is to get this x down, what we need to do is come up with some method of doing that, and the method is logarithms. So the first thing we would do if we were creating an inverse function is switch the x's and the y's. So we get x is equal to b raised to the y. But then we run into trouble really quickly, because now how am I going to solve for this y value, which is why we need something like the logarithm in order to help us out. So what we end up doing is we say we're going to create a symbol. Just like we created a symbol for square rooting, we're going to create the symbol, the log base b, and we're going to do that thing to both sides. Right? So just like square rooting is an operation, taking the log base b is also an operation. So we have the log base b of x would equal the log base b of this b raised to the y. And just like over here, square rooting and squaring cancel each other out. Over here, when we take the inverse of an exponential, this log base b and this b are going to cancel each other out, and we're left with y. And so on the other side, we have the log base b of x is equal to y. And since we started off here, which was trying to find the inverse of y is equal to b to the x, it means that this thing down here, the log base b of x, must be the inverse of b to the x, or I'll say y is equal to b to the x. Right, so all these things are inverses of each other. Very common mistakes, which should not make sense if you understand that this is just bananas, is to think that if I have the log base, say, 2 of x, to think that this is the log base 2 times x, right? So that doesn't make any sense, the same way that this doesn't make any sense, because the log base 2 is an operation like addition, subtraction, multiplication, division, cube rooting, exponentiating. It's an operation that we're representing by a symbol. So in the next video, we'll actually do some practice on how to take something that's in exponential form and run in logarithmic form, and vice versa, which is kind of the key of algebraic thing that students do first with logs.